Morning. Yay! All right, it is morning, and for all you people, it is Friday.
Finally.
It is Friday. Now, okay, I don't know if you guys care about this too much, but I kind of do. Tomorrow is Saturday school. I am not going to be there. I'm not going to ask you or try to do anything. Our first time that we're actually going to meet outside of school, or I'm sorry, our next time is going to be during spring break. The first 2 days of spring break. So the first day we're going to do a practice AP exam. Okay, I'm going to grade it, and then the next day we're going to do, it's called a reading. So we're going to actually go through each one of the questions. I'm going to hand it back to you, and it's going to be your study material. So, and I'm going to go through it and grade it and show you the grading rubric for it. Okay, so if you guys could mark your calendar the first 2 days of spring break. Okay.
Spring break?
Huh?
When is spring break?
Let me see. This is week 7, so after 2 more weeks. Yeah, spring break. 2 more weeks away. Okay, so it's really helpful every year. You know, people actually, if you get time and actually just submerge yourself into just the math and not have to worry about your chemistry or your biology or your English or your history, whatever the else you guys have to work on all the time. Okay, it makes life a whole lot easier, because if you're only focusing on this, it's less to worry about, because your life is just going to be this for 2 days. Okay, so you're not sitting there and be like, oh crap, I got to get this done for chemistry later on. Okay, or what does Banta teach? Yeah, okay, yeah, that thing. Because a lot of people come in here, they're like, man, got this, got that. All right, anyway, no offense, Banta, we love you. Hey! All right. Okay, so we are doing this one right here. So let's go ahead and I'm going to start off with something on this one right here. So what part of this don't I like? Cosine 2 theta, right? So what part of that do I want to get rid of? The 2 theta. So the 2 theta, that's important, because that's the ugly part. But right now it looks way too ugly. So there's a lot of things I could do with this to make it not so ugly. All right, so what do you think I should do first to make it not so ugly? Huh?
Is it double angle theorem?
No. Okay. When I look at that problem, I say, F that. What can you factor out?
1/2.
1/2, right? That's going to make it a lot easier, isn't it? So if I take out a 1/2, what am I waiting for? Oh, that light in the back actually does make a big difference. It's off right now, so that's why I'm like, Friday, you said, wait.
No,
No, did you not like that part?
it's fine. I was just...
Okay. Now, next thing, I'm going to do fundamental theory of calculus part 2. Can I break it up into 2 separate integrals? Yeah, so it's going to be the integral of 1/2 bracket. So I'm going to bring this all the way out, because I'm going to do it into 2 separate. And it's going to be the integral from 0 to pi over 2 of 1 d theta minus the integral from 0 pi over 2 of cosine 2 theta d theta. Now does it look easier? It looks a whole lot easier, right? But I still got that little nasty, 2 theta in there, which I could use sub anyway, right? So now this whole thing turned into, oh, that's not going to be that hard, is it? So let's go ahead. So this is just, I'm expanding this and making it into more steps than I needed to. I could have just took out the 1/2 and say, hey, let's integrate that with the u sub. But breaking it into smaller parts just so you guys could actually see it different ways. Okay, so I'm going to go ahead and integrate this. So that's going to be 1/2 bracket, and it's going to be the integration of 1 d theta is not x, theta, right? Yeah, there we go. So it's theta from 0 pi over 2 minus, okay, so now over here I'm going to have my 2 theta is equal to my u, so my du is equal to 2 d theta, right? Yes? So it's 2 d theta, and then I only need to get rid of my d theta, so what am I going to do with that 2? We can divide it, right? Yeah, we can divide it, right? So divide it by 2. So I'm going to substitute my d theta with du over 2. Okay, so now, what could I do with that 1/2 that the du is? I can put it in front of my integral, right? So I'm going to put it in front of my integral. So I'm still going to write that out. So it's 1/2 my integral from 0 to pi over 2. And that is going to be, what am I going to write? Cosine of u du. There you go. Okay, so now integration of cosine, sine. Okay, so it's going to be, so I'm going to start from here. I'm just going to go negative 1/2 of sine of what? Yeah, let's put it back. 2 theta, right? From 0 pi over 2. I just put it back. Like I said, I'm doing like a whole bunch of extra steps on this, so I'm not missing out on anything here. All right, so let's go ahead, top minus bottom. So my first one is going to be, yeah, I'm going to leave the 1/2 for right now though. Let's mess with that later, because I'm going to have to distribute and distribute over here. All right, so this is going to just give me pi over 2. And top, so sine at 2 times pi over 2 is just going to give me pi, right? So what is sine at pi? 0. Okay. Sine at pi is 0. Yes? Minus the bottom. So 2 times 0 is 0. So sine at 0 is 0. There we go. Ooh, 0 minus 0. So what's my answer going to end up becoming here? Pi over 4.
But shouldn't that be like 1 out, right? Outside of the parentheses. Oh, no, to your right. Yeah.
Oh, I'm sorry. You're right. You're right. Should be 1/2. All right, so now that changes my entire computation. So 1/2 times 0. 0. There we go. Yeah. I screwed up, but yeah, it's kind of like when the clock is right twice a day, a broken clock. Yeah. So even though if it's just sitting there, it's still right twice a day. All right. Yeah. I just lucky on that one, I guess. Okay. So yeah, pi over 4. So not too bad. I hope. Integrate even and odd functions. Integrals of even and odd functions can be simplified due to symmetry. Illustration conditions of theorem that follows. So, if it's going to be this, now, from here to here, this piece right here, okay, if they're symmetrical, I'm finding it under the curve, right? Say yes.
Yes.
If it is symmetrical, I only have to go from wherever the middle of it is, because sometimes it does give me issues trying to do both. I stop, okay, so right there at the middle where it's actually folding in half, and I'm going to change my integral so it's 2 times 0 to a. Does that make sense? And this is an even function. Think of x squared, which is a parabola, x to the 4th, okay, like this, right? Yes? Okay. Come on, you guys, I send you the little thing with the hand signs and everything. Okay, now show me x to the 1st. Yay. Yeah, right? Yeah. Come on. Okay, sine wave. You know what? If you can't laugh at this or even try to enjoy something about this, then anyway. All right. So here's another one. An odd function. Here's my sine. Here's my sine. So this right here. What is bad about all this right here?
It's negative.
It's negative. So in an odd function, if it is symmetrical, the bottom of it is going to cancel out the top of it.
How do you prove that it's symmetrical?
Okay, so this is going to be symmetrical. So it would be equal to 0 because the negative portion of it would cancel out the very good. It would cancel out the positive. Okay, so that's in an odd function. So how would I fix that one? If I wanted to have a remember, so when we're talking about displacement, right? We're going to displacement, and my total distance traveled, right? Absolute value, right? Absolute value, total distance traveled. So that's me walking to Douche Bros. The distance traveled is 2 miles, right? But my net displacement would be 0. Yes? Because I'm going to end exactly where I start. So my net displacement is 0. This is an example of a net displacement of being 0, right? Because my odd and my even both cancel out. Okay, not my odd, but my negative and my positive both cancel out. Okay, so there's my net displacement being 0. My total displacement, if I wanted the total displacement of this, I would actually have to take from here in an odd, right? In an odd, I would go from 0 to a. I would change the integral to be from 0 to a and double that. Okay? Does that make sense? So everything I just did and said, I'm hoping you guys feel good about it. All right, let's see. Is this the last one?
Yeah. The last 2, yeah.
Last 2. Okay, so I want to see you guys try these right now. So A is what type of function? Odd. B is a even. So if you notice, okay, if I'm going from my bounds right here, okay, if I do this correctly, it is going to be odd. What is my area of A supposed to be?
0.
It's supposed to be 0. So if I do it correctly, I should come up with 0, right? And if I do this one correctly, it should be 2 times whatever that is. All right? So try it, please. I'm going to pause this. All right, let's see what we got now. So I'm going to integrate. So this is going to be x8 over 8 minus x4 plus x squared, bless you, over 2 from -3 to 3. So you guys should be able to see this from here. From this point right here, you should be able to see it. Because if I'm plugging in 3, that's in, this one right here is a even number, right? Even number. So even number here, even number here, even number here. So all my exponents are all even numbers. Okay? So when I plug in 3, it's all going to be that positive number, right? So when I plug in -3, it's all going to be the exact same positive number, right? It's going to be the exact same positive number because with the even exponents, it's going to always be a positive. So there we go right there. So I should see that one's going to come out to be 0. Okay, you could do the plugging it in. I don't want to do 3 to the 8th power. No clue. All right, yeah, no.
65, 61.
Is it?
Yes.
Okay. So, or you could have just did, you know, by plugging it in, you know, be like, hey, 3 to the 8th, okay? A 3 to the 8th also because it's going to be, you know, and just cancel things out too, right? So, yeah, save yourself a little headache for that. Okay, next one. So, I'm going to do it as is first, and then we could actually see that it should be double whatever I have. So, let me see. x5 over 5 minus x cubed over 3 plus 3x from -2 to 2. All right. Let's see. So 2 to the 5th, so it'd be 32 divided by 5. So 32 over 5 minus 8 over 3 plus 6 minus the other side, which is going to be a negative 32 over 5. And that's going to be a minus plus, so minus, so this is a plus 8 over 3, and this is going to become a minus 6. All right, so if you notice, as I distribute, this becomes a positive, this one right here becomes a negative, and that one becomes a positive. So if I distribute all that, let's see, I have this one here, and this one here, so that's 2 of those. 2 of those, and 2 of those. Okay, that's because of the symmetry here. So the left side and the right side, the top and the bottom of these bounds are going to be the same. So my answer should be just twice whatever I have there, right? Twice whatever I have there. So I don't want to mess with all that. I'll just mess with this. Let's say common denominator is going to be 15, so this is going to be times 5, which is going to be 160, minus 5, which is 40, and plus 15 times 6, which is going to be 30, 60, 90.
Multiply the 32 by
3, yeah.
by 5.
You said 32 by times 5, but it should have been times 3.
Because they are.
Yeah, I did 5 and 3.
No, you multiplied 32 by 5 rather than multiplied it by 3 because it
6 times 15.
what? No, the 32.
There's a 32.
The 32 over 5?
It should be times 3, right?
Yeah.
Oh, you're right. I'm sorry. Thank you. Remind me to throw some, look, I'll throw some candy at you. But, good job. All right, 96.
No!
All right, 96 over 15. That's going to be twice all that. So let me see. That's going to be 56 plus 90 is 146 over 15. So 146 over 15 times 2 is 280, 296. I have no clue. I'm kind of winging it here on the math here, so I need some help. Huh?
Right? Because 1 is 6 times 2 is 12. Right?
So we got 146 here, right? So 146 times 2.
So 6 times 2 is 12, so the last one would have to be 12.
292. Okay, 292. Thank you. See, something felt wrong.
You're close though.
15. And I don't know, can I reduce that either? So 11, 12, 13, no. All right. Okay, so you guys feel okay about this? I'm hoping. Now, since I finished the notes, that means I'm going to give you guys the next 2 days to please work on this. So please, don't think just because I am not teaching a lesson that you just could just work on chemistry or something like that, or Banta's class. You know, work on this. Try and get it done so I can help you. All right? Like, share, and subscribe. Hit that notification button. Patar.